Hi everyone, just a quick repair video here. I managed to pick up this P6046. It's a Tektronix differential probe for use with an oscilloscope. It's an active probe, so it comes with its own amplifier. So if I just take a look at it here, bought it off eBay. It's faulty from the States actually. So obviously it's 110 volts. So here's the probe itself there, which seems to be in reasonable condition. The actual amplifier itself and the power supply. And looking at the power supply, it's obviously sustained some damage. It's actually the 110 volt plug there is actually broken, as is the case itself. So I suspect this is what's actually faulty in regard to the purchase. So we'll be hooking up the power supply, see if we can convert it to 240. I presume there's a transformer inside, so I kind of actually think it'll be wound single winding for 110 volts. So we might need to look at the manual, or perhaps even find some way of replacing the transformer and putting the internals of this power supply into my own enclosure with obviously a British 13 amp plug on the end. And hopefully once we get that up and running, I can start using it. The first thing I want to actually start using it for is actually to do some testing on my homemade power supply there, just to see what sort of noise I'm getting, true noise that I'm getting on the output there. Of course my own oscilloscope just has single ended probes there, and of course you can use two, a combination of two, which we've seen in the net quite lately, but it's a bit hit or miss, and you've really got to muck around to actually get a nice true display for in regard to noise. So the plan was, if I could get this cheap differential probe up and running, see what sort of resolution I'm getting on the output, and it'll be another tool for the workshop. Okay, so we've got it out on the workbench here. Here's the actual amplifier itself, just a quick look at that. We've got the vertical scale here, which seems to be intact. We've got the plug there for actually connecting the probe itself, and a balance control there. On the back we've got an output, be a buffered output, single-ended, and we've got the actual lead that comes from the actual power supply itself. There's no socket or plug, it's just hardwired directly from the power supply to the actual amplifier itself. So we're not really interested in this amplifier at the moment, we're more interested in the power supply. So let's get it open. Well, that's what I call a fairly compact power supply. And we've got a damaged component there for sure. If I can just zoom in on that, you can see that's, I don't know if that's a cap or not there, but certainly that's seen better days. I'll do some measurements on that. The fuse is intact. I've got a large transistor there, a little bit corroded on its when it mounts onto this assembly here. I notice also that these 3-pin devices here, there's a few of them scattered around. They're actually in sockets, which is a bit unusual. So we've got the 110 volts here coming in, and that's it coming onto the transformer there. Looks like we've got yes, I think we've got two windings. Possibly this is one winding here and the other winding at the other side, and being 110 volts, they're both in parallel. So and then they've got the secondary over on the other side there. So we might actually be a bit lucky here, and I could actually rewind the two primaries in series, and therefore I can run it off 220, 240 volts. So we'll have to desolder that and have a wee look. I may look online and see if I can find a schematic for this here, and see what we can get, and we'll try powering up at that. Okay, a quick schematic. Here's the existing setup here with the number and all on. Live and neutral there, live coming in through the first coil, and then the second coil is simply in parallel with the first one there. This one's 154 ohms, this one's 136 ohms, so hence I'm getting the 72 ohms overall across the live and neutral. So here's what it's going to look like after it's rewired. We've still got the same 154 and 136 coils there, but quite simply I'm going to rewire it slightly, and it's going to be in series there. So this is still 4, 2, 3 and 1, and that will give me the same secondary voltage output. Okay, I've disconnected the 110 volt plug, and I've removed the primary wiring that was up onto the transformer there, and I've linked out the two coils on the primary side. So there's that two soldered connections there on terminals 1 and 4. That's basically my live and neutral input there. Okay, as you can see, I've got a blown component there, or at least a discoloured component there. I've been trying to identify that particular part on the PCB, and although most components have a silkscreen to identify the various parts, this particular capacitor, I presume that is, and the one at the other side are not actually detailed. But looking at it, and the fact that there is another one, I'm kind of half thinking those are the main caps across the bridge rectifier, effectively on the plus and minus 50 volt lines there, which I think that's probably the case. So I did actually manage to download a couple of schematics and PCB layouts for the boards, and as it turns out there is actually two versions of this assembly here. And if we just move over to the my computer monitors here, I didn't bother printing them out, sorry about that. You can actually see here's basically the layout for the 100 volt board. You've got the 26 volt board at the other side there. This is a 100 volt board, and you can see the two capacitors there, C302 and C303. However, my board doesn't look like this. If you look next to C302, you've got two terminations there for the wiring coming off of the board there, an A and a B. But if you actually look at my actual board, there's the C302 there. I've actually got 3 connections there for 3 wires coming off the board. So clearly that layout's not this particular revision. So back across to the other layout for the other schematic etc. that I found. Here's the same 100 volt board there. It's the other way around compared to the other one. You can see there's C302, and there we have 3 external connections marked A, B and C, which is exactly what I've got in mine. So this particular manual here is relevant to my actual board, and as you can see they've still called it C302 and C303. So here's the schematic for the boards that I have actually printed out. We've got a 26 volt board here, 100 volt board there, and looking for C302, there it is there. It's 110 microfarad. It's one of the decoupling caps after the bridge rectifier, as you can see. I'm looking at the parts list in the manual. It's 110 volt, 110 microfarad, 75 volt electrolytic cap. So I'll see what I can find that's around about that value, and then try and get it to fit it into place. I probably haven't got one that size and shape, so I'll have to see what I can do. But luckily, because I'm not putting the actual PCB back into its original enclosure, I'm probably going for something bigger. Don't really mind if it actually sticks out the side of the board at all. It's just more important to get the right value and voltage etc. So I'll away and do that now. Wow, and as luck would have it, I've got an old stock electrolytic in stock actually. There's a 150 microfarad 100 volt electrolytic, which isn't that much different in size to the original, a bit larger diameter, but I should manage to get that in place. So it's a little bit bigger and both voltage and capacity, so that'll just be perfect for the job, I think. Okay, now as you can see, that's the capacitor fitted in place. Made sure it's the right way round. We've got the negative end of the capacitor on C302, goes away off to the other capacitor, so that's that track there, going away off to this side here for the C303 there, so that's the right way round. But you know what? Looking at this capacitor here, at face value, looking at it, does actually look okay. However, if I look really closely, see if I can zoom in here, you can actually, I think I can see a little bit of bulging on the side there. So I suspect that this capacitor is also probably going the same way as the other one, except maybe not so bad. And it's the inside that I can't see in this capacitor, and I think it's probably going the same way. So I have actually found another one, so you know what, I'm just going to change that one out as well. And there's the second cap removed, and yes, I think you can actually see it does look like there's some damage started to there. The coating's actually started to lift, probably in much the same way as the other one did. So yeah, good call to change that one out as well. Okay, so I did want to find another way of verifying I've got these caps round the right way. So if you look at the positive end of this cap here, it goes down onto the PCB down in there, and there's actually a resistor that's in line with this series of 3 connectors here, and it's actually there's a group of pads there, so it's actually connected to that resistor there, down behind the connectors, like I said. And if you look at the over here, sorry about the panning, but if you look over at the component layout there, there's C302, and what I think is the positive end, there's the 3 connectors there in line. You've got R321 right in behind it there, so that's that R321 is actually connected to that end of the cap there. So back across now to the schematic, there's R321, and there's where it ties across to the capacitor there. So that's basically, and verifying that I've got the positive end of the capacitor attached to 321, that's actually the 50 volt rail, that one along there. So we've got that confirmed, and of course the other one's dead easy because there's a big large track between the 2 capacitors there. So I think we've got the capacitors correct. So let's hook it up now and power it up and see what sort of voltages we get at the various test points. You can see that C, E, B and D are the main rails. You've got the plus and minus 50 volts, and you've got the 20.6 and the minus 6.2. So hopefully you'll be able to trace them and verify those voltages are correct. Okay, so what we'll take a look at first is there's terminal C, that should be plus 50 volts, and terminal E there should be the minus 50 volts. So C plus 50, E minus 50. So we'll go down onto the board here. Give it power up, and this is C here, there we go, 49.4 volts positive, and E, I think that's E there, and there we go, minus 49.4 volts. So that's all well and correct on the 100 volt board there. So now we'll flip it over and see if we can get some the lower voltage on the 26 volt regulator board. Flipped over. Okay, so looking at the schematic once again on the 26 volt board, we've got B should be giving me 20.6 volts positive, and D should be giving me minus 6.2, so it's B and D there. So down on the board there, I've looked at the actual component layout for the board, and this is D in the corner here, and B is actually there. So we'll just power it up. So this is D, which is minus 6.3 I'm getting, minus 6.2 is supposed to be, so that's fine. And over here we've got B, which is 20.28, should be positive 20.6. So that's perfect, I'm getting the correct voltages output from the power supply there. Okay, the next thing to do is to start thinking about the enclosure. Like I said, don't really want to use the original enclosure here, mainly because it's built for a 110 volt socket on there, and the other reason is because it's actually split, it's actually broken there. So I'm going to toss that away and I'm going to come up with something else. So what I'd like to do actually is to put this in a small enclosure, maybe something about that size, maybe offset it to one side, and give me a chance to put a power switch and then a panel mounted fuse on the power supply, and then have a 240 volt AC input tail basically grommeted into the enclosure. That's what I'd like to do, but really I've really got to look around and see what's I've got around. I don't really want to buy anything, I'm just going to use what I've got lying around and see what I can come up with. So I do actually have one or two other enclosures here, housings that I've got in my little stock. All sorts of different shapes and sizes, from die cast to ABS boxes and this sort of thing. Unfortunately this is not big enough. A lot of basically boxes to really incorporate an LCD, so I've got all sorts of Hammond enclosures and large sort of portable handheld equipment boxes, all that sort of thing. So I've kind of got all sorts in here, down to a nice little metal one here. Unfortunately that one's nowhere near big enough. So I've got a few there, but nothing really big enough for what I'm looking for. So we'll have to think of something else. Let's go and have a look at the Bits and Bobs box. See what I've got here. So basically a lot of AC adapters here, but nothing really there that's good enough for the job. One. Desk cables, and here's some more bits and bobs here, old enclosures. Now there's an idea, built-in mains plug. I wonder if that's big enough. Let's get back to the workbench and have a look. And here it is alongside the power supply. Could I squeeze that inside there? It would certainly be a lot easier if I didn't have that metal plate, so I might see if I can remove that. I don't know how important that is for the structure of the actual power supply, but I'm sure I could adapt something to do that instead of having this big overhang right around the power supply. And if I was just restricted to basically the size of the PCBs there, maybe I could get it inside there. So well, let's rip it apart and have a look. Okay, I've stripped down the power supply a little bit. As you can see, I've removed this back plate here. In actual fact, it's a moulded, a cast aluminium plate there. But actually, it's used to hold the PCBs up onto the transformer there. Okay, so what I've actually done to save some space, I've actually cut down the plate that was on the end here. As you can see, that's a new size there, because it actually forms part of the structure that holds the boards together and also bolts them up onto the transformer. So it's actually quite structural, this plate here, so I couldn't really just remove it. But as you can see, I've cut it down so it's just you know, well within the PCBs there. I've also taken opportunity, since I had it apart, as I've actually soldered two wires there onto the back of the fuse carrier there. Because I'm looking to put it inside this new enclosure here, I really want to retain the internal fuse, so I've hooked that back up. So I will actually be, you know, hooking it up onto the transformer there, but I just done that while the plate was off. It was a lot easier to get to the fuse carrier there. So next thing now is to actually see if it'll fit inside the new enclosure. Okay, so the first thing I had to do was snip away some of the moulding in here that was actually getting in the way when I actually offer up the PCB. So I've kind of cut that down, not quite all the way down, but hopefully enough. I still want the PCB to sit slightly proud of this bottom here, because actually the 240 volt mains is actually coming in here. It's actually recessed slightly into this, as you can see, this recess here, but I will need to put down a bit of card, you know, like you'll find in high voltage power supplies over there, to properly insulate it against vibration, against away from the actual PCB, the power supply. So here we go. So I've got the board here, and it should actually just go in. As you can see, the capacitors are tight, but it does actually go down, and it sits. It's actually sitting fairly well down into the base of the enclosure there. So the next thing to do is to look at the height that I've got. So here's the actual cover, and if I just offer that up there, that is tight. But I think I might manage to just get that on there, just and no more. So I think we'll go ahead with that basically, and see what we can do. I'll try to turn it around the other way, because this cable here, the output cable there, would actually probably prefer it to come out the bottom at this actual cutaway here. So it would actually be easier if it was facing that way. So I don't know. No, it's not going to go in really. The plastic mouldings here, this end of the enclosure, actually stick further into the middle of the box, and it's just interfering with those large electrolytics more than I'd like. So I think what I'll have to do is I will have to put it round that way, and then just run this cable round the power supply and out. As you can see, I've still got enough room there to get access to the fuse if I need be. So I think we'll go ahead with that. I think we'll wire it all up and get the lid on it and see where we are after that. Okay, that's it assembled. I've put a bit of fiberglass card underneath the power supply there to insulate it against the back of the AC terminals there. But I've also coated the tops of the terminals where I soldered them with epoxy resin as well, just to insulate them all the better there. And with the fiberglass card, which is basically bulletproof, I've got the power supply sitting down as far as it can go. So I've popped the fuse back in there, and I've got the top here. I've actually cut a little channel there for an exit for the cable there. I'm not going to bother routing it round to that side, I don't think. I'll just have it coming out the top, and with the, it just fits in no more. I mean, I'm just putting the tiniest bit of pressure there just to bring the halves together, but as you can see, it's not too bad, and there's my exit there. That's not too bad either. So that's basically it. So I'll screw it together and power it up and make sure it's working. Okay, that's the enclosure back together again, ready for testing. So let's plug it in over here. Let's switch on, and of course the main amplifier unit's got no LEDs or any kind of indication of power, but I do know that the centre pin on the connector there is, I think it's either plus or minus 50 volts, so we'll go and probe that right now. Okay, so let's probe it here. There we go, minus 50 volts on that pin there. I think maybe here's the positive 20.23, so I think that's a good one. Next thing to do, I suppose, is to actually hook it up to scope, get the probe connected, the actual differential probe, and get it working. But I think that's a good enough replacement power supply enclosure for the original one. I'll probably just put my own label on here. I'll take that one off. Don't want to give anyone any surprises about what's inside there. So job done.